We've seen ID versus VDS for length of 2 microns. Now let's reduce it and observe what we'll see. For that, type vim and file name day2 and press tab VDS. Now here you can see we are doing it for typical corner, and here we are taking width of 0.39 microns and length to be 0.15 microns, and here again doing simulation DC simulations and sweeping VDS from 0 to 1.8 volts with a step of 0.1 volts, and we are sweeping VGS also with a step of 0.2 volts. Now let's run this. For that, type ngSpice and file name. Now type plot minus VDD branch. Here you can see ID versus VDS for different values of VGS, and here if you can observe, for lower values of VGS it is showing quadratic behavior, whereas for higher values it is showing linear behavior. If you can see it, VGS of from VGS of 1 volts it is showing linear behavior. Now, if we want to plot peak current, for suppose if we consider this plot for VGS of 1.8 volts, and if we want to plot peak current for this curve, just press left mouse button, and if we see, it is around 196 micron. And similarly, if we want to see for ID versus VGS, let's exit this, and now we want to observe ID versus VGS. Type vim day2 VGS tab. Here we are again keeping W and L to be same values, W 0.39 microns and L to be 0.15 microns, and here we are keeping VDS constant to be 1.8 volts, and we are sweeping only VGS value from till 1.8 volts with step of 0.1. So here we are observing only for one plot with the keeping VDS constant of 1.8 volts. Now let's see. Type ngSpice and file name. We now type plot and minus VDD branch. If you can see, this is the ID versus VGS curve for VDS of 1.8 volts. Since we are taking length of 0.15 micron, which is short channel, you can observe it is showing linear behavior. And that's it. You can continue with day 2 MCQs.